Welcome everyone to class number 3 of our space science classes. My name is Keith Wasilewski. I am going to be your host and tour guide as we look at the terrestrial planets. So I have a little solar system diagram here. We're going to go, we did talk about this in the intro, but we're going to take a little bit more of a deep dive um, into these interior planets. So terrestrial planets, we call them that. Terra is the Latin word for Earth, not the planet Earth, but for solid material. These are planets that you can land on. Uh, I mention that because that's not true of all the planets. The gas giants are really just that. They don't really have a surface. The interior planets do. So we have Mars, Earth, Mercury, and Venus. If you notice, two of the planets are closer to the sun than the Earth is, so they orbit around the sun. And Mars, of course, orbits a little bit further out than the Earth. And then we have the asteroid belt. So we're going to go right into it. I'm going to stop sharing my model for a minute. And I'm going to go here. So we're going to start right at the beginning of the solar system, Mercury. Remember, big thing about Mercury is there isn't a whole lot of detail to see on Mercury. It's too close to the sun. It's very, very bright. The thing with Mercury is that we can see it at all. That is the big deal with Mercury. It's so close to the sun. It orbits the sun every 88 days. There are only certain times that we can view Mercury. The only way you can see Mercury on Slooh, again, it's one of the sorry, one of the rarest and most elusive objects on Slooh. The only time you can get a Mercury mission is at the very beginning of the night or at the very end of the night, and you have to watch these missions live. There's no way to schedule them. It's too close to the horizon, too close to the sun, only about 10 degrees or thereabouts. You have to watch these missions in person. That's the only way you can capture an image of Mercury. It is, like I said, one of the rarest birds that we have in all of Slooh. Again, very difficult to capture even in person. I took this picture of Mercury, I think 2 summers ago, again, right before the sun rises. Venus, another object similar to Mercury. Again, its orbit is within the orbit of the Earth, so it moves more quickly around the sun. Venus, thought to be Earth's twin. I want to take a look at this diagram. What we're going to talk about today is not the planets so much. When I was invited to do these space science classes, I was asked to share some of the things that you might not read on the internet or you might not hear about in class. And one of the most difficult things to talk about is planetary motion. So I want to just take a quick look at this diagram because, as I know Gretchen will remember me saying many times, we will never use this diagram, okay? This is the textbook example of what you see whenever anyone talks about planetary motion. It is the most confusing thing in the world. I understand what this stuff means, but it confuses even me. So what I did is I went ahead and I made my own diagrams. So when we talk about Mercury and Venus, they are only visible, like I said, either just before the sun rises or just after the sun sets. Two times, most of the time, Venus and Mercury aren't visible at all. Here's one of the reasons why. We have a planetary alignment that we call inferior conjunction. Now, before I talk about this, is my diagram better than this? You can put in chat which you like better. All right. We have a planetary lineup of Earth, Venus, and the Sun. So Venus and Mercury will do the same thing. These planets aren't visible, okay? When we have this arrangement that we call inferior conjunction. Inferior meaning they don't have a complex. They are just lined up this way between the Earth and the Sun. Now, Venus and Mercury are a little different. If you sat in on the Jupiter show that we did on Saturday, these planets, when we see them move, they are the ones actually moving. So I talked about opposition with the Earth and Jupiter. The Earth is the thing moving. Here, Venus and Mercury are the planets moving. They're closer to the sun than we are, which means they move more quickly. The Earth, as Venus makes its way around the sun, this is one of the first times that Venus will become visible. Uh, here we have this 90-degree arrangement again. Venus at greatest western elongation. So Venus will come out from behind the sun or in front of the sun and will start to make its first apparition, its appearance as a morning object. And then we'll reach this point, this 90-degree relationship. And then it will continue to loop around and be on the other side of the sun, not visible, and will loop around the sun and become visible as an evening object. So the sun will set, Venus will be visible right after the sun sets. So on either side of the sun, not visible. Venus and Mercury, the same thing, only visible when they're on this left and right-hand side of the sun. Venus, we talked about the phases of Venus. So just like the moon, we see phases of Venus. We do not see planetary detail with Venus. Again, it's too bright, it's too close to the sun. It's also covered in a thick, dense layer of clouds, so we don't see detail. What we see are the phases. So we can think of as Venus passes in front of the sun, this is sort of like the new Venus phase. This is when Venus is an early morning object, loops around the sun, and then it will be an evening object. Now, one of the things I want you to notice here is the motion. So if we were to plot the planets against a starry background, against the night sky, you don't see this on Slooh, but it's important to know and understand. Movement will appear against the background stars from right to left. Okay, this has nothing to do with the movement of the night sky. It's if you plotted the movement of planets over a course of several nights or several months even. The movement is going to appear from right to left. That is the motion that we call prograde motion. That is the normal motion of planets. So if we imagine Venus, even though it's not visible for much of its movement around the sun, it still is moving from right to left. It will reach a point in the sky where it does not appear to move against the background stars, and then will track back on itself. So prograde motion is that right to left. When it starts to loop around this way, like on the bottom, we call that retrograde motion. This is important. All the planets will go into retrograde, but it's a little different with the interior planets with Mercury and Venus because their orbit is actually inside the orbit of the Earth. So we will actually visibly see, if we were to plot this against stars, the planet move in this backwards motion. Now, if you look up retrograde motion, especially with Mercury, you are going to see everything mentioning, all the links are going to be mentioning astrology. You'll find almost nothing about astronomy. It's very difficult to find anything because people freak out when Mercury and Venus go into retrograde. I don't know why. Astrology has no basis on really on science or what we see. So just be aware of this retrograde motion with the interior planets, Mercury and Venus, because it actually is looping around the sun inside of the orbit of the Earth. Why is that important? Because the other planets will go into retrograde, but for a different reason. All right. We talked about the light source. So we know that when we see the phases of Venus, this is what's happening. The Venus, this would be Venus at greatest or eastern elongation, right? The sun is over here. Here's the light source illuminating Venus from here, and then we see that dark shadow on the side. So Venus images from Slooh. We can see by looking at this, based on what we've already discussed, the sun is over here, where Venus is illumined here on the left side. So we know that this is appearing just before the sun rises. This is from that period of where Venus has just passed in front of the sun and is approaching or at greatest western elongation, right, where it is a morning object. Very visible on Slooh. Like I said, we don't see planetary detail, but we do see this beautiful, beautiful phase. Same idea. Venus is passed in front of the sun. It's going to start making its way around the other side. We can see that the crescent is getting a little bit smaller. This is actually probably a waxing Venus getting bigger. And again, the sun is over here to the left. illuminating it from the sun. It's a morning object. What about the other side? Well, this is it at eastern elongation, or where it's just passed from behind the sun and is now an evening object. The sun is here, the sun sets. Venus will appear to have this phase. And again, just another example of the same thing. Venus. I think that's my last Venus image. So let's take a quick breather here, Gretchen. Do we have any questions in the chat? I'm going to go back to my slides, and we're going to take it.
Just yet.
We're going to take a look at the other terrestrial planet. Earth is a terrestrial planet, but we're not going to talk about Earth. We can't see Earth, obviously, from the Slooh telescopes, although I think there is a project in the works to use some satellite images that I think Slooh is going to partner with. But we're not going to talk about the Earth today. Now I have to find my Zoom controller. Uh-oh. Okay, here we go. So the next planet we're going to look at is this, Mars, the red planet. So here it is with a side-by-side comparison with the Earth. Mars is smaller than the Earth is, beyond the orbit of the Earth. The thing about Mars is its path around the sun is about half as fast as the Earth. So a Martian year is about 600 and some days. So when the Earth moves around the sun, it takes about twice as long for it to catch up to Mars as it does some of the outer planets. All right. So again, we need a starting point. Mars at solar conjunction. We can see the Earth, the Sun, Mars. Mars not visible when it's in this arrangement. Now, Earth here is moving faster than Mars is. When we talk about planetary motion, this is a must-do quest if you haven't taken already. The Kepler, in the footsteps of Kepler, talks all about planetary motion. In a nutshell, the further a planet is away from the sun, the longer it takes to orbit the sun. The corollary to that, the flip side, if you take geometry, we can infer that the closer a planet is, the more quickly it orbits around the sun. So we talked about that. Mercury and Venus orbits the sun faster than the Earth does. Mars orbits a little bit slower than the Earth does. So it is the Earth that is going to come into these relationships. So when we talk about the morning apparition of Mars, which is what's going to happen as the Earth orbits around the sun, Mars will become a morning object. It is the Earth that is moving into that relationship. We move into this area. We talked about greatest western elongation with the planets that are further away from the sun than the Earth as we talk about quadrature. So western quadrature is this 90-degree relationship. Okay. Sun, Earth, Mars, that the Earth comes into after we had solar conjunction in the previous slide. Mars in opposition. So if you were on the Jupiter star party, we talked about opposition. This relationship, Sun, Earth, Mars. Why is opposition a big deal? Because that's where we see all the beautiful planetary detail. The planets will also appear to be larger. I have a comparison slide here somewhere that we'll take a look at. But again, it is the Earth, because it moves more quickly around the sun, that is coming into this position with Mars. A lot of times you'll hear, especially on the internet, Mars makes its closest approach, which I think is January 16th of 2025. Mars is not approaching anything. It's the Earth that's coming into this relationship with Mars. So that's our big takeaway from this. Opposition, yes, this is a big deal. January 16th, we've talked that we may want to have a star party for opposition of Mars. Kind of a big deal, like I said. Not every year, like Jupiter, Saturn, Uranus, Neptune. More like every year and a half, every 2 years. I forget the exact amount of time, but it is kind of a big deal. All right. Then if we had Western quadrature, we have Eastern quadrature. The sun sets, Mars is right behind it again, and that's because of the orbit of the Earth around the sun. Mars taking on this Eastern quadrature, this right angle again. Okay. So when we talk about Venus and the phases of Venus, we talk about the light source. So what happens with this? Now, this is an image that I took of Mars from some type of simulation. Mars at Western quadrature, and what do we see? We see a phase. Now, this was a big deal on Slooh a couple years ago, where somebody was observing over several nights this Martian gibbous phase and couldn't understand what was happening. This is what's happening. Now, there are scientific groups that study only planets, and this Mars at quadrature, or this gibbous phase of Mars, is a big deal. Okay, this is written about very widely in some circles. And we can see again what's happening. If we looked at that Western quadrature image. Um, the light source is over here. So we can imagine Mars rising before the sun does and having it exhibit this not full Mars, right? Can we see it? Absolutely. This is an image that I took some time ago of Mars at this time period of Western quadrature, where we see very clearly the gibbous phase. Here's the simulation. This is the actual image of Mars itself. So a great opportunity. And I give you these dates for quadratures because this is what we can expect to see. Opposition is where we see planetary detail, but at that eastern and western quadrature, those time periods, this is where we get to see the gibbous phase of Mars. If you want to score major points, okay, in your observations, get an image of Mars when it's in this gibbous phase. Okay, this is again a very, very uh, a rare sight on Slooh because you really have to kind of look for it. It's one of those things you have to know when it's happening, and it's just a great opportunity to make a great observation. Okay. So we had the Western quadrature, then we have the Eastern quadrature, right? Mars moves, we move past opposition. We're out of that arrangement, that planetary lineup with Mars. We have Mars now on the flip side. It's on the other side. We can think of the sun being here, so to the right. So as the sun sets, Mars will be illumined on this side, and the gibbous phase will be over here to the left. Okay. Now we talked about retrograde. With Mercury and Venus, retrograde occurs because they orbit the inside of the sun, inside of the Earth's orbit. With Mars, it's different. With Mars, as the Earth comes around into this period of opposition, Mars will appear to move backwards across the field of stars. This isn't like Mercury and Venus. Mercury and Venus really are doubling around. They actually are passing between the Earth and the sun, and they're moving in that opposite direction, not Mars. So you have to kind of follow what's happening here and watch it a couple times. As Earth closes in on Mars before opposition, Mars will appear to move against the background stars. That's the M1 up here. The example that I use for this to try and understand what's happening, it's an illusion, first of all. Mars is not moving backwards. Okay. Mercury and Venus are moving backwards. They are moving in a different direction because they're inside of the orbit of the Earth. Mars is not moving, but it has the appearance of moving. And I give this example. You are a passenger in a car and you are in the passing lane. You approach the car that's in front of you. It's getting closer, it's getting closer, it's getting closer. You reach a point where you are alongside of it. It doesn't look like it's moving. Then it will appear to be moving backwards. The car is not moving backwards. You're just moving faster than it is, but it will have the appearance of moving backwards. And that's the example that I use here. That's what happens with Mars in retrograde. All the planets that are beyond the orbit of the Earth, Mars, Jupiter, Saturn, Uranus, and Neptune, will go through this retrograde loop, including the minor planets. We will enter into opposition with Ceres and Eros and some of the other things. And they will also go into a retrograde loop. So it's an important thing to note. Another great observation, a nice little tidbit to add in your planetary observations on Slooh, to mention uh, that the planet is in retrograde, if it is at that time. Mars right now actually is in retrograde. I think it started on December 6th. So Mars right now is appearing to move backwards across a field of stars. You will not see this on Slooh because in order to get planetary detail, we have to kind of zoom in so we don't see the stars. But if you were to go outside and look for it, you would see this effect. Again, here's a diagram of some of the retrograde motion of Mars. Again, prograde is from the right to the left. It will reach this point here, go backwards, and then start moving to the left again. Okay. Next slide. So I think I want to take a break here, and we are going to go into something else. Let's check the chat, see if we have any questions. I think my diagram is much less confusing. I thought, gee, thanks. Have any previous space missions visited Venus? Yes. The Soviets, I should put up a slide, shouldn't I, Gretchen? Let me go into solar system scope first, and I will talk about that. I've got all these screens open. I'm so sorry, you guys. Okay. Advanced portion of screen. Okay. That's not what I wanted to do. Okay. Do we have my solar system model? Okay. So the question was, have any missions gone to Venus? Why don't we go to Venus? Let's go to Venus right now. Yes. The Soviets have sent two probes to Venus. We would expect uh, Venus to be hospitable. This was the general theory with Venus, that it was Earth's twin, good candidate for having life, maybe future exploration. The probes that have gone to Venus disintegrated because its atmosphere is extremely hostile. Sulfuric acid, basically, is what the clouds on Venus are made of. So when you send a spaceship or a spacecraft to Venus, it disintegrates, basically just melts, because as it goes through this thick, dense layer of cloud, it is eaten up and chewed away at by the sulfuric acid that is on the surface of Venus in this cloud layer. Okay. So that was the Venus question. So yes, we have gone to Venus, but there isn't much to see. The missions don't last very long. All right, now let me go back here. I forget why we came here. Let's go back to the solar system. Oh, now I know. We wanted to go to Mars. I wanted to look at. So we did talk about this in the introduction, that Mars is covered very heavily in iron. And although it does have a weak atmosphere, it does have an atmosphere. And that iron oxidizes, which basically creates a type of rust. That's what gives it that reddish, orangish color. Mars has two moons, but these aren't moons like we think of, like the four Jupiter Galilean moons. They're basically just these pieces of rock. Okay. And there are different theories about where these moons came from. Theory one is that they formed at the same time, or roughly the same time that Mars itself did. Probably not the case, because usually we see a spherical shape to the moon when that happens. Another theory is that they are captured, much like in Jupiter we have, the 95 moons. They're not really moons. They're captured pieces of space rock that get too close to Jupiter or get sucked in by its gravitational pull and become an object that becomes in orbit around the planet. Mars isn't really big enough. If you notice, it's smaller than Earth. So the idea of it being something that was captured through the Martian gravity, probably also not the case. Third theory is that these are the results of an impact in on Mars. Think something like an asteroid crashing into Mars, kicking up debris, which then enters into orbit around the planet. Um, does that sound crazy? No. You know why? Because we have meteorites that have been discovered here on Earth that are pieces of Mars. In fact, we have Slooh members that have some of these pieces of Mars here on Earth. Sounds crazy, but yeah, there's an impact on Mars. Pieces of Mars go floating out into space. They get captured by the Earth's gravity, and they become meteorites. So that's kind of also one of the theories of Mars. Uh, the interesting thing about these two satellites around Mars is that their orbit is decaying. They are eventually going to crash into Mars. And we believe that some of these objects have actually already done that there were more than two large pieces of rock in orbit around Mars that have already crashed into it. So, interesting thing that, again, this is the first planet outside after the Earth that that has satellites, that has things around it. Um, Mars, the interesting thing about Mars is this is the first planet in the solar system, actually the only planet that we can see planetary detail on. With Venus and Mercury, they're too close to the sun. Venus is covered in clouds anyway. All you're ever going to get of Mercury, like I said, is the fact that you see it is kind of the big deal. Venus is covered in cloud and it's very bright, so you're only going to see that. Mars is the beginning of where we start to see planetary detail. Jupiter that's not surface detail, and the other planets, again, we don't see surface detail. Pluto is just plain too far away to see anything. So Mars is really the only planet where we get to see uh, this planetary detail. So I'm looking at some diagrams here. I want to get into the share here and get back to this. I want to go back. Why are the moons of Mars a big deal? Because if you can believe this, for as small as they are, now remember, Mars is smaller than the Earth, very far away, and its moons are pieces of rock, and yet they can be captured using the Slooh telescopes. This, again, is one of the rarest images I think I've ever seen in all of Slooh. Mercury's rare, but I mean, you can capture it. Here, a person scheduled a mission and was able to capture the moons of Mars. This is just insane, okay? When I look at this, I'm just watching it's like a 3-frame animation. Uh, it's still amazing that someone was able to do this. Like I said, they're so small. To schedule a mission like this, you would have to know when the moons were visible, right? When they're not in front of Mars and when they're not behind the planet, when they're out here in this loop of their orbit. Again, an incredible image. Mars at opposition, like I said, it's about 50% bigger. So this is from an opposition, I think the last time around. Not only is it bigger, it also gets brighter. The the smaller the number, the brighter it is. So negative 0.5, that's its brightness level at opposition, negative 2.7. Planetary detail. These are things that we can look for. Now, Mars, because it has a tilt, also goes through seasons, but because it takes twice as long as the Earth for it to orbit the sun, its seasons are twice as long. Just a map of some of the features that we can expect to see if you take a Martian image and you see some of the detail. There are utilities online that you can go and look for, and it will tell you what it is that you're looking at. You don't have to even consult a map like this. You just go to the utility and it tells you what details are visible on Mars. Some things to notice of note, the polar ice caps. Again, that will depend on what season Mars is in when it's at opposition. You may see the polar ice cap. The southern polar cap is much smaller. You may see some of the details. You may see, um, here's an image of Mars. I think this is a Slooh image. I'm not sure exactly what we're seeing. That looks like a part of the North Polar hood, which is what they call that. There's the cap, but there's also an overall sort of a shroud. There's another image. Really, really nice detail on Mars. This is what we're looking for. And like I said, it's the only planet where we actually see the surface. Mars, again, you can land on Mars. This is the actual surface of Mars. These are not clouds like we see on Jupiter. This is the Martian surface. Ah, Mars dust storms. So last time we were at opposition with Mars, everybody was very excited to see some of this great Martian detail, and we got clouded out. Clouded out because Mars has these terrible dust storms, and when you have a dust storm on Mars, it obscures all that detail that we're looking for. So this is something that can happen too. You get excited, we can move into opposition with Mars. Mars will be very good right now. Unless we have a dust storm. And then it just appears to be this orangish color. Just a couple images. Olympus Mons, the largest mountain volcano uh, on on Mars. It's the largest in the solar system, actually. Olympus Mons, this base, if you can see around this, would be the size of the entire country of France, just to give you an idea of how large Olympus Mons is. Another image of Phobos and Deimos, the two moons of Mars. An image of some of the Mars exploration. We don't really talk about space exploration too much, but there are things all over the surface of Mars, very, very heavily studied now, different rovers and scientific instruments and things that are on the surface of Mars. So I think we're going to take a little bit of a break here. I don't know, Gretchen, do you want to take a Slooh break? If you are looking for good images of Mars, I'm going to show you where to find them. Let me get here and share. I have to go advanced. Sorry, you guys. All right. So when you're on the Slooh dashboard, you just go up to the magnifying glass and you type in Mars, M-A-R-S. And you click on observations, and you will see in order some of the top Martian observations that have been made on Slooh. Top because these mean these are the ones that are most liked. And you can see there's a whole bunch of them, Martian detail. I'm not seeing a gibbous Mars. Here's someone talking about the dust storms. And you can do this with any object. So if you ever want to learn what other Slooh members have done and what they've seen, the best of the best, this is the place that you want to go. Okay. So we have somebody putting something in chat. Okay, email them to you.
Yes, Keith, someone is asking for your wonderful diagrams that they think are so much better. And I said that we can definitely send those off by email.
Yeah, I make those using some planetarium software. It's so much better than that diagram. And the thing is, that diagram that I shared at the beginning is the one that's used in like every book on astronomy, and it's on just about every web page. It doesn't confuse me because I know what those things mean now. But if I had to start by looking at that, there's no way I would. Yeah, I mean, it's just not good. So we can make those available to you. It's all open source stuff. So that's our little foray and our little exploration into the terrestrial planets. Venus, Mercury, Earth, and Mars. We'll talk about Earth a little bit when we talk about the moon. And that's all I have for you. Thanks everybody for coming. Talk to you soon.